Good afternoon, everyone. This is Cassie Powers. I'm Chief of Staff here at NASEO, the National Association of State Energy Officials, and we're very pleased to welcome all of you to NASEO's Severe Summer Weather Energy Outlook webinar. We host this every year with the committee here at NASEO to help educate states and prepare them for energy security implications of extreme weather, including hurricanes, storms, droughts, and wildfires, as well as some of the economic impacts that are the results of those storms. So before we begin, I would like to first say a couple of thank yous to our key partners. First, a thank you to the U.S. Department of Energy's Office of Cybersecurity, Energy Security, and Emergency Response for their support of this webinar, and as well as their support overall for the energy offices and energy security planning, and to help them both respond and to emergency responses. Also, a special thank you to our speakers from the National Oceanic and Atmospheric Administration, from the U.S. Energy Information Administration, from the North American Reliability Corporation, from Colorado State, from the National Interagency Fire and Coordination Center, and then, of course, again, to CESER for their participation in our webinar today. NASEO, for those of you who don't know us, we represent the governor-designated energy offices in each of the states and territories, and our members play a pivotal role in energy security as the leads within their states for energy emergency planning and response. The state energy office directors and many of their staff serve as the ESL 12, or the energy support lead, for providing technical assistance, as well as helping to facilitate response and restoration during energy emergencies. State energy officials, they have and they continue to make significant resilience investments and advancements by strengthening regional petroleum coordination and response, by expanding their engagement with industry, and by crafting actionable energy security plans to prepare their state for the various natural and man-made emergencies and disasters as they arise. One thing I also want to mention just before we get started is a quick plug for an upcoming NASEO and DOE event. NASEO is hosting an energy security boot camp on June 13th and 14th in Minneapolis. So this is coming up soon, and Sarah Trent on the NASEO team can provide more information. The boot camp is open to state energy security planners and energy emergency responders, including, of course, state and territory energy offices, as well as PUCs, governor's offices, emergency management agencies, and others. And so feel free to reach out to Sarah if you have questions. And finally, on an administrative or housekeeping note, the webinar is recorded. And so if you have any questions as well, please feel free to drop those into the Q&A, and we're going to have opportunities for questions after each of our speakers. And so with that, I am pleased to introduce our moderators for the day, who are also the co-chairs of the Energy Security Committee here at NASEO. Ben Holton from the Tennessee Department of Environment and Conservation, and Audrey Ahlstrom from the Alaska Energy Authority. And so Ben and Audrey, I will turn it over to you.
Thank you, Cassie, and appreciate the introduction and taking the time out of your day and to support the webinar. And NASEO always does a wonderful job in assembling all these disparate speakers to tell us a whole lot of information. So I'm not going to take much time to say a whole lot, but basically that this is one of the best things that I think the committee does all year round, and that we do it in the summer, and then we do it again in the winter. And it's a great way to give you some situational awareness about threats that are coming, things that are happening, and how to also assess a lot of that information, or better, a lot of times with us, it's knowing who knows what you don't know. So with that, I'll turn it over to Audrey.
Thank you, Ben. Hello and welcome to the call, everyone. As Cassie mentioned, I'm Audrey Ahlstrom. I'm the director of the Renewable Energy and Energy Efficiency Program at the Alaska Energy Authority. So this call helps states prepare for energy implications due to extreme weather. And in the fall, as Ben mentioned, NASEO hosts the Winter Energy Outlook. And so I'm hoping, like the Winter Outlook last fall that told us we'd have an excellent El Nino winter last season, which resulted in wonderful snow for skiing. I'm hoping this call and our panelists will share well in for a great summer of sun and enough rain to keep the fire danger low, of course, without many issues to worry about. But in any event, we'll be prepared. On our lineup today, it includes Dr. Phil Klotzbach, a senior research scientist at the Department of Atmospheric Sciences at the Colorado State University, who will discuss the Atlantic forecast for the 2024 hurricane activity, followed up by NOAA's Matthew Rosenkrantz from the Climate Prediction Center and Matthew Elliott at the Storm Prediction Center. They will speak to NOAA's 2024 seasonal hurricane outlook and implications for the Pacific regions. Then we'll hear from Angelina LaRose, the Assistant Administrator for the Energy Analysis at the U.S. Energy Information Administration, who will discuss the short-term energy outlook and implications to the electrical grid. We'll hear an overview of the 2024 North American Electric Reliability Corporation's, or NERC's, Summer Reliability Assessment and its key findings from Stephen Cortiro, engineer. And then we'll have Jim Wallman, meteorologist with the National Interagency Coordination Center, or the National Interagency Fire Center, who will share factors impacting wildfires and outlook of the wildfire season. Then we'll close with Megan Levy and Adam Shapiro of DOE's Office of Cybersecurity, Energy Security, and Emergency Response, or CESER. Now I'll pass it back to Ben to help us get started.
Thank you, Audrey. And so the first thing we're going to do is have the outlook for the hurricane season, Atlantic hurricane season. And Bill is going to kick us off with what looks to be an exciting year.
Well, thanks so much, Ben, and thanks, Audrey, for the introduction. So I'm Phil Klotzbach. I'm in the Department of Atmospheric Science at Colorado State University. Our group has done Atlantic seasonal hurricane predictions since all the way back in 1984. So if we can just go ahead to the next slide. We'll dive right in and talk about the outlook. And so this outlook was put out on the 4th of April, and it calls for an extremely active Atlantic hurricane season. I'm sure a lot of you have heard of the outlook from CSU or from NOAA, calling for pretty similar levels of activity, a very active season. We're calling for a total of 23 named storms. So those are tropical storms and hurricanes, winds of 39 miles per hour or greater, 11 of those 23 becoming hurricanes, and of those 11, 5 becoming major Category 3, 4, 5 hurricanes on the Saffir-Simpson hurricane wind scale, winds of 111 miles per hour or greater. That compares with the long-term average of about 14, 7, and 3, so you can see well above average. We also forecast several integrated metrics, including accumulated cyclone energy, which accounts for storm frequency, intensity, and duration, so it weighs long-lived major hurricanes very heavily. We also, starting last year, started forecasting basically wind energy generated by hurricanes in the western half of the basin, primarily because obviously that's where almost everyone lives in the Atlantic basin that's impacted by hurricanes. So we wanted to kind of focus on Western Atlantic, and then typically the ACE in the western half of the basin is higher in years that you have La Nina conditions, and we'll talk more about why that's the case here in just a minute. So if we can just move ahead to the next slide. This is not a CSU seasonal hurricane forecast already done. I really like this comic. This is Dr. Bill Gray, the founder of the seasonal forecast, looking into his crystal ball and saying, verily, I see 17 named storms. That's not how we do these seasonal forecasts. We use historical weather and climate data. And basically what we're looking for is precursor signals. So basically what sets of climate conditions historically have preceded active seasons, and alternatively, what sets of climate conditions have preceded inactive seasons. So one of the first relationships that Dr. Bill Gray noted, if we can move ahead to the next slide, is the relationship between El Nino, La Nina, and Atlantic hurricanes. So El Nino is warmer than normal water in the central and eastern tropical Pacific. La Nina is colder than normal water in that same region. And so the question is, why would El Nino and La Nina impact Atlantic hurricanes thousands of miles away? And it's through what's known as teleconnections. Basically, when you change water temperatures in one part of the globe, it changes where basically the atmospheric circulation response. And if we move ahead to the next slide, what it really does is it changes levels of vertical wind shear, which is a change in wind speed and direction with height in the atmosphere. In an El Nino event, you tend to shift the thunderstorms towards where the waters are the warmest. So they shift somewhat from Indonesia more towards the central tropical Pacific, and the upper level outflow, so outflow from those thunderstorms at 20 to 30,000 feet, is very strong out of the west and tends to really increase your vertical wind shear. So near the ocean surface, the winds blow out of the east. High up in the atmosphere, they blow out of the west. So you have a pretty strong change in wind speed and direction with height in the atmosphere in El Nino. Hurricanes don't like wind shear. It tilts the hurricane circulation. You're less likely to get the pressure fall that you need to get the winds to accelerate in response. You mix more dry air into the storm, all of which tends to squelch your hurricanes. So El Nino tends to have more shear, La Nina tends to have less shear, and that's one of the first relationships Dr. Bill Gray discovered. We use a lot of other predictors as well, and I'll talk about a couple more of those as we dive into the 2024 outlook in more detail. So if we move ahead to the next slide, I did want to show the scale of these forecasts. So this is the 41st year that our group at CSU has been doing these forecasts. And so a couple of things I want you to take away. One, the forecast skill improves as we get closer to the events we're trying to predict. Makes sense, similar to the way that your forecast for tomorrow is going to have more skill than your weather forecast for 1 week from now. We're closer to the events we're trying to predict. And while the 1st of August is 2 months into the hurricane season, the season starts officially on June 1st, about 95% of your major hurricane activity occurs after the 1st of August historically. So it's one of the, just a reminder that, June 1st comes around, don't necessarily expect to see much storm activity, even in a forecast very busy hurricane season. A good piece of news is the red columns are higher than the blue columns, which indicates increased skill in recent years. 2 reasons for that. One, the historical data that we build the models off of is better than it used to be. We have better models to take the historical observations and give us a more realistic view of what the past looked like. We also use climate models. Now, these are not climate model simulations for 100 years into the future. These are climate model forecasts for, say, 3 to 6 months from now. And we're not looking for forecasts for one specific day. We're looking at forecasts for a longer period, say for a month or a 3-month average. And those forecasts also show reasonably good levels of skill, so we get a better idea of things like what El Nino is going to look like, how hot is the Atlantic going to be like, and what is the shear response going to look like. All these things have gotten better, and that's contributed to improved skill in recent years, and hopefully continue to improve skill as we move ahead into the future. So going ahead to the next slide. This is the current sea surface temperature anomaly pattern. So here when we talk about anomalies, we're talking about differences from average. So warm anomaly is warmer than normal. And if we look at this, obviously a couple of things really jump out. One, the globe is very warm, and you may also be drawn to the fact that the Atlantic is. It's a big blob of red over most of the Atlantic, and obviously that is not good for the upcoming Atlantic hurricane season. So if you can push the advanced feature, we're going to focus on 2 areas here. The first is the eastern and central tropical Pacific. That blue rectangle denotes what's known as the Nino 3.4 region. That's what happens when you allow scientists to name things. But that region is the region that NOAA uses to monitor El Nino and La Nina conditions. So right now we're at the last gasps of El Nino. We're likely going to be transitioning over to La Nina for the peak of the Atlantic season. If you move ahead, 1 slide, please. If we look at this second rectangle, that denotes the Atlantic hurricane's main development region, so named because that's where the hurricanes form and intensify in the Atlantic. And you can obviously see the waters there are extremely warm. We're still running at record warm levels there. So if we move ahead to the next slide, the reason why we're generally pretty bullish on a transition over to La Nina is that the waters at the ocean surface, there's still a little bit of warmth there, but beneath the ocean surface, the waters are fairly cool. And why that matters is because you have trade winds blowing from east to west across the tropical Pacific. As they blow across the tropical Pacific, that tends to encourage basically upwelling or bringing up of colder water from beneath the ocean surface up to the ocean surface. So those colder waters are likely to continue to emerge, and we're likely to transition over to La Nina conditions by the peak of the Atlantic hurricane season. If we move ahead to the next slide, we can see that NOAA is quite aggressive at calling for La Nina for the peak of the Atlantic hurricane season, about a 75% chance for August through October, which are the peak 3 months of the hurricane season. And if we move ahead 1, you can see the arrow highlighting August through October. So now let's move ahead to the next slide. And you can hit the enter key 1 more time or the advance 1 more time. That denotes what's known as the Atlantic, again, the Atlantic main development region. That blue rectangle, if you average the water temperatures over that box, they are still running at record warm levels. It's about 1 to 1.5 degrees. Some places 2 degrees Celsius warmer than normal, or about 2 to 3 degrees Fahrenheit. Doesn't seem like much to people living in the middle latitudes, but in the tropics, that's a big deal because it's more fuel for the storms, but it also is associated with lower pressures and a more unstable atmosphere. So when you get your easterly waves or thunderstorm complexes coming off of Africa, they're more likely to develop and intensify into hurricanes and potentially major hurricanes. And I think one of the sobering things is if we look at this current plot, we can see kind of the spatial orientation of those sea surface temperatures. And if we move ahead one slide, this is the optimal pattern associated basically with busy Atlantic hurricane seasons. And it's almost a perfect match for what we just saw, which is, again, one of the reasons why our group and most other groups doing seasonal hurricane predictions have come across with such robust hurricane forecasts for the 2024 hurricane season. So now let's move ahead to the next slide. It's not just water temperatures at the ocean surface. If we go beneath the ocean surface, this is looking at ocean heat content, so basically how much fuel is in the entire ocean. It's also running well above average, so that red line is 2024. The blue line is the long-term average. In this case, it's the last 11 years, which generally have also been fair on the warm side. On May 27th, we had ocean heat content values that we normally get in the middle part of August. So that's not good. Again, these water temperatures, it's not just at the ocean surface, but you have a lot of fuel deeper down in the ocean that these hurricanes are likely to be able to fuel themselves off of in 2024. The line just to the right of the red line, the dark red line, is 2023, which was also an extremely warm year, but 2023 had El Nino, which did help at least dampen storm activity in the western part of the basin. So while the season itself was quite busy, we didn't have much storm activity in the western half of the basin, and thankfully from an impacts perspective was pretty benign, with the notable exception of Hurricane Idalia. So moving ahead to the next slide. Oh, sorry, yeah, that black arrow just denotes where we should, basically where we are on May 27th. So we can step ahead to the next slide here. Obviously, the million-dollar question everyone wants to know is where these storms are going to go, and there's not a lot we can say this far in advance. This is a forecast from the European Center for Medium Range Weather Forecast model. Here, anything in red is higher than normal expected track densities. And you can see there is a lot of signal in the western part of the basin. Likely a lot of that is due to the fact that in La Nina conditions, you really knock down your shear in the Caribbean. And if the Caribbean becomes more conducive, obviously, one, it increases your, obviously increases the odds of storms forming in the Caribbean, but those storms in the Caribbean can get picked up by troughs and brought up into the Gulf of Mexico, perhaps impacting Florida as well. So if we step ahead to the next slide. We also use analogs, which involves going back into the past and looking for years in the past that had conditions most similar to what we currently see and what we expect to see for the peak of the season. So in this case, we were looking for years that basically were transitioning from El Nino to La Nina and also had extremely warm tropical Atlantics. Now, none of these years were as warm as what we observe currently in 2024. But if you move ahead to the next slide, we can see that the average of these 6 years was the average of these 5 years was a very busy hurricane season. So keep in mind also in 1878 and 1926, we didn't have satellites, we weren't flying planes into storms, so we likely underestimated storm activity in those years. But I do think 2010 and 2020 kind of serve a good point for some of the challenges that you have with seasonal forecasting. In general, more active seasons have more landfalls, but you can get very lucky, like 2010, where we had 12 hurricanes in the Atlantic Basin, which is a lot, and none of them hit the US. On average, about 1 in every 4 does. Whereas 2020, we had a lot more storm formations in the western half of the basin, and obviously a lot more impacts as well, both especially along the Gulf Coast, as well as in the Caribbean, and impacting significantly also Central America. So if we move ahead to the next slide, we also issue probabilities of landfall. These probabilities are based on historical odds, which are the numbers in parentheses, and the numbers to the left are the probabilities for 2024. Basically, they are adjusted based on the forecast for the western half of the Atlantic Basin. We have these probabilities at these broad levels, and we also have these probabilities all the way down to the county or parish level on our website, which I will put up in just a minute and when I finish my presentation. So moving ahead to the next slide. There is uncertainty associated with these forecasts. So we give you the midpoint, the number that you may hear reported in the news, but there is certainly uncertainty associated with these forecasts. This is based on the historical error of the models, and these ranges are similar to ranges you might hear with a forecast from NOAA. So we do provide those forecast uncertainty ranges, which are based on kind of the historical error associated with these forecasts. So we move ahead to the next slide. These forecasts are updated. We'll put out our next forecast on the 11th of June. We don't anticipate any significant updates at that time. Updated again on the 9th of July, the 6th of August, with a final verification on November 26th. And as I wrap up, I just want to highlight one last thing with the next slide. We also have seasonalhurricanepredictions.org, which is a website that our group partnered with the Barcelona Supercomputing Center. And we have about 30 different groups submitting seasonal forecasts to this website. And if you go ahead to the next slide, you can see how these forecasts are displayed. They're color coded by agency. So purples are private sector weather companies, blues are government agencies, and greens are universities. One thing you will note is that almost every group is forecasting a very busy hurricane season this year. On the y-axis, the red dot represents the observed number of hurricanes to date, and the orange dot represents the average of all the different groups issuing seasonal forecasts. So with that, I will wrap up, and we can just advance to the next slide. That's my contact info. So thank you very much, and I'll try to answer any questions.
Sure. Thank you, Phil. And I'll remind everybody, I forgot to tell them on that up front, that if you do have a question, please put it hit the Q&A down at the bottom, and that will ask the question, and then we can do that. We're also working on getting the chat enabled if we can, so that we can give you the link for NASEO Bootcamp. But you can also Google NASEO and Bootcamp, and it'll come up for you. So if anybody's got a question for Phil, please let me know, and we will ask that. One of the ones, though, that I was wondering is, do you think, I know you've got all this other data, you're using several different forecasts. Do you think that it's becoming harder to forecast hurricane season, given all the uncertainty and instability in general?
Yeah, I mean, certainly hurricane forecasting is more challenging when you have a lot more variability. So we've had some years in recent years, like 2013, where we had 2 hurricanes. Seems hard to remember seasons that were that quiet. And then we have years like 2020, where you had 14 hurricanes that are really, really busy. So, as you have that volatility, it gives you kind of better chance to predict, but it also does become quite challenging, especially when you have a year, say like last year, where we were kind of dealing in a set of circumstances we hadn't observed before, where we had a record warm Atlantic, which would tend to make the season go bananas, and then also a strong El Nino, which tends to really knock down your storms, and kind of how that was going to play out, was a big question. And I know, our group, NOAA, everyone was kind of stressing the high level of uncertainty with the forecast last year, even though the forecast ended up most groups verifying fairly well. So yeah, certainly the forecasts, are challenging every year. This year seems like it's more straightforward, and that pretty much everything is pointing the same direction, but I'll get back to you at the end of November.
That's right. Well, forecasting is always, we'll check back in with you then, and certainly appreciate the update. Are there any other questions for Phil? All right, it looks like we're quiet, so I'll keep us on track, and appreciate it, Phil. And we'll move on next to Matthew Rosencrans with the Climate Prediction Center at NOAA, and Matthew Elliott, also from the Storm Prediction Center.
Hi, everyone. So, Matt Rosencrans here with NOAA. Go to the next slide. So go to the Eastern Pacific outlook. I want to talk a little about that. We are looking at, it's in the bottom of the middle of the storm, 11 to 17 named storms, 4 to 9 hurricanes, and 1 to 4 major hurricanes, with an ACE of 50 to 110% of normal. Phil did a fantastic job kind of describing what the ACE is, so I don't really have to go into that too much, explaining what that is. Now, it's interesting, the East Pacific that's a below normal season, mostly below normal for them. So normal for the East Pacific is 15 named storms, 8 hurricanes, 4 major hurricanes. You can see that on the slide there. So most of those ranges, the named storms and hurricanes, are below the normal value, and the major hurricanes just equals, the upper end of it equals the major hurricane climatology. That results in a 60% chance of a below normal season. You can see that in the middle plot there. There's a little bit of warmer water that is forecast in some of the models east of Hawaii. So the Central Pacific Hurricane Center wanted to hedge the bets there a little bit and go with only a 50% chance of below normal, and a 20% chance of above normal. So a little bit different than the Eastern Pacific there. And Central Pacific, again, they average 4 to 5 tropical cyclones. That does include tropical depressions that are in that outlook. And the reason that is because the infrastructure in Hawaii is much less resilient to disruption. It takes a longer time to get things out there, right? We have to drop in a lot of supplies by ship. It's a multiple day journey rather than on land on the CONUS, where you can just kind of bring in a fleet of trucks and bring in a lot of supplies very quickly. So next slide. And then one of the things that can happen, we noticed last year with Hurricane Hillary, is that these storms recurve into the southwest U.S. and can bring tremendous flooding and tremendous damage. The most common for those recurrings is the kind of second week of September into the end of September as the jet stream kind of gets going more. You also kind of have that's the end of your seasonal activity in the Pacific. It's when your sea surface temperature should be the warmest. So some of these storms can hold together a little bit further going north along Baja there. So there's a lot of confluence of factors kind of picks that up into the rainfall days in the Southwest. So again, they can result in a lot of flash floods and a lot of heavy extreme precip amounts. And some very quick discharge into the river systems out west. It's very rare that a lot of that moisture will make it actually up into like the Colorado River Basin. Most of it does stay in like the river systems in Arizona, and then eventually translate into New Mexico and sometimes even into as far east as Texas. So next slide. So what led to that kind of East Pacific outlook? Next slide. The transition to La Nina that Phil talked about. He really talked about this in great detail and hit on it. But we are expecting the transition to La Nina. You can even see in the left-hand image here some of those cold temperatures developing in the central Pacific, right around 120 degrees west on the equator, kind of right in the region of the Nino 3-4 that we monitor to determine the El Nino status. Or La Nina status, right? So we are currently in an El Nino advisory right now because at the beginning of the month, we're still in El Nino status, but that has dropped off rapidly. As you can see, right-hand plot, basically the middle plot too. So it's, 3 up from the bottom, the Nino 3.4 plot there shows that kind of rapid decline in the last month. Middle plot of the middle row, middle column, everything does show very little wind anomalies there. During the last month, so we're not having anything to reinforce these sea surface temperatures staying in an El Nino state. So that should rapidly continue to cool. So next slide. Again, that percentage chance, very similar to what Phil showed. So the interesting thing is that La Nina, while Phil talked about having an increased threat in the Atlantic, it decreases the chance of tropical storms in the Eastern Pacific, kind of like a seesaw. You end up with shorter tracks in the East Pacific. You end up with kind of more storms that kind of veer off towards Baja, and they have just shorter lifetimes in general because you end up with sea surface temperatures and a little bit higher pressures near the surface, sea surface temperatures below normal and a little bit of higher pressure near the surface. So kind of almost exactly the opposite conditions that we're expecting in the Atlantic. So that's why the forecast there from NOAA was for a below normal season in the Pacific. So next slide. And also the wind shear, if we look out over the Pacific, just kind of south of Mexico and straight down from Baja, these two plots both show a lot of wind shear in the Pacific. So again, opposite to what Phil talked about in the Atlantic, where the Atlantic had below normal shear. In the Pacific, we are expecting above normal shear and quite a bit of it. So that would inhibit tropical storm and hurricane formation development there. Next slide. So again, East Pacific, 11 to 17 named storms, 1 to 4 major hurricanes, a negative PDO and a La Nina both aligning to reduce the potential for tropical storms there. So that's the tropical portion of this. If we go to the next slide. I'm also going to talk about the drought in the U.S. So last time we talked, we had a very significant drought across the plains and parts of Florida. This year, we still have some of that remaining residual drought across the plains, specifically in the state of Kansas. But we have most of the drought in Texas and eastern Texas has been ameliorated. But southern New Mexico and parts of Texas really missed out on a lot of winter rains this year. And that's kind of a lot of that's kind of some of the upstream and headwaters for the Rio Grande. So I might expect some low flows in there if they don't recharge with some precipitation Now we know East Texas has had quite a bit of precipitation and quite a bit of stormy activity. Lower Colorado River there, going down through Austin. It's definitely a different river system, and they've had their challenges there. But the one further to the west, even some of the drainage basins, the Arkansas River, they've had a bit of low flows going to them there. Not noticing too many low flows in the Mississippi near Cape Girardeau, kind of where the Ohio River and the Missouri River come together. So those are there was worry about that earlier on, and that's why you still see some drought depicted there near the Boot Hill, Missouri. But not seeing too much impacts there because it has been decently wet in the plains and also into the Midwest where the drainage waters come down. So about 2/3 of the water that goes in the Mississippi actually comes from the Ohio River Valley side. So, and that's been a pretty wet area. So next slide. Forecast going forward. Unfortunately for South Texas and New Mexico is for that drought to either develop in the areas that are kind of in the yellow here or persist and intensify in the areas that are in brown. So I wouldn't expect much recovery in any kind of flows in the Rio Grande or any of the other tributaries. They kind of have their headwaters in New Mexico. We are expecting a bit of potential drought development and through August, also in the Pacific Northwest. I know there's a lot of hydropower concerns up there. There's a lot of drought development expected there, and that this means that they're at least likely to get to a D1 category. So in the drought monitor, you'd expect to see at least a moderate drought there, the D1 category. I have to look up the exact value for what that is. D1 is an abnormal. D1 is, moderate drought. So you'd expect to see that there based on this outlook. You could see some D2 severe drought there later on as you start to get into later August. But they did have some rains there recently. They had some rains, some late season rains there that may stave it off. So next slide. And this is looking on the links here. They'll be included in the PowerPoint, I guess, when they get sent out. We are mapping the reservoir and drought statistics versus our drought outlooks. So you can see where the reservoirs here are in the green, they are above normal. And then, so you can see in the Pacific Northwest, while they are forecasting drought, there's quite a mix of the reservoir status there, even east and west of the divide. But then as you get down into New Mexico, you start to see some of the reservoirs that are low. You get to central Texas, some of the reservoirs are low, and they're in an area where drought is likely to persist and develop. So that can be the more worsening case down there. We also do look at the intersection of hydro plants and power plants versus the drought outlook as well for the monthly drought outlook. And we do it for the seasonal drought outlook. We have all these statistics for months and seasons. So where would those intersect with the forecast drought conditions? And those are all on the website here. You can see the hydro plant statistics that are in the drought removal area is 42, but there are 31 plants that are likely in the drought persistence or intensification that intersect with it. Next slide. Overall, the outlook for July, August, September has largely above normal temperatures for most of the CONUS. There's a bit of more uncertainty in the northern plains, and that extends down into the Ohio Valley. That's really where the trends show the most variability and least signal for where we could see least confidence in any signal. So that's why we have the equal chances there. The Southwest, with the potential for the droughts to develop, you would have a reinforcing factor with warm temperatures, drying out soils more, bringing warmer temperatures, drying out soils more. You have a feedback cycle like that. There's also a large trend in temperatures in the summer in the Northeast U.S., and that's kind of factored into this outlook here. For Alaska, we are seeing in the eastern half of the state above normal temperatures favored there. Could lead to a bit of earlier meltouts than maybe was forecast earlier in the year. But then you do have some below normal temperatures to the south and west. That's mainly that there are some below normal sea surface temperatures off to the west there, and those tend to not change during this period of the year. There's not a lot of big storms that come through there to stir things up. So once that kind of sets in June, you kind of don't change that too much. Kind of a dipole, dry in the west, wet in the east. That's mainly if a predicting, from a stronger ridge over the Atlantic Ocean, pushing more southern more southerly feed into the eastern U.S. So you can have some more storm track from there. And also with the hot temperatures and a ridging building over the southwest, during La Nina years, you can tend to get a ridge building in the southwest, pushes some of your moisture north and even east out of your monsoon region. So you don't really get good monsoonal flow in these La Nina years. Next slide. So this is a graphic also our week 2 hazards. So this is valid from June 5th to June 11th. This is from yesterday, but it's updates every day at 3 p.m. It's something that we're highlighting now. We do have a threat of excessive heat into the Intermountain West, which this excessive heat and this block and this time of year could end up leading to a lot of early season melt off and a lot of an enhanced amount of discharge into the river systems during this time period. On the right is when we actually take out any threat that's moderate on our probabilistic hazards, and we put it into like a composite map. So if there was a moderate risk of heavy rain, it would also show up in the map on the right. We do also highlight areas of potential for a rapid onset drought, which is drought development in the next 2 to 3 weeks. We are highlighting southern Texas, again, where that water flow from the river systems coming in there would be low, and then also precipitation locally is forecast to be low in the next 2 weeks. We do highlight temperatures, hot and cold, heavy precipitation, heavy snow, which this time of year isn't such a threat. High winds, usually winds above anywhere that we're expecting winds 25 miles an hour sustained for the day. Rapid onset drought and also flooding possible in week 2. Next slide. And the CPC does also have a week 2 to 3 tropical hazards product where we highlight the potential for tropical cyclone formation and or heavy rains, but anything kind of related to tropical variability. If it's a tropical storm that's coming into the Gulf and then recurving and bringing the precip to the eastern U.S., it'll be highlighted on here. If it's a threat that's a cold front coming down from not from the tropics, is likely not on here. One of the big things this graphic does is let us give the forecast for 2 to 3 weeks in the future where we expect tropical cyclone development, and it does appear that we have a slight signal into the southern Gulf of Mexico June 12th through the 18th in the kind of the Western Caribbean wrapping around Central America. You can see that in the kind of the candy cane stripe there, which indicates at least a 20% chance of formation for tropical cyclones in the kind of Bay of Campeche and Western Caribbean. So,
All right, Matt, do we need to move? I'm already into the question period we have. So we have much more before Matt's going to be chiming in?
no, I'm done.
Okay, wonderful. So Matt, that'll take you down to about 5 minutes, unfortunately.
Oh, that's okay. I'll try to move quickly, and if you can share the slides, hopefully, then most of the material is available online too. So, go ahead.
No, go ahead. Yeah, we'll share the slides after.
As we all been talking about, it's been a very busy start to 2024 so far for the severe weather season. In fact, if you combine April and May, we are in the top 3 now in terms of tornadoes, confirmed tornadoes going back to 1950. And even if you look at the whole year, January to May, we're in the top 5 for confirmed tornadoes. And if you look at all hazards across the board, at least preliminarily, we're only behind 2011, which was a historic year. We're well behind that. It wasn't a historic year, but it's been very busy. Now, having said that, we're on a kind of a summer call here, summer outlook call. You're here at the Storm Prediction Center, of course, we're dealing with forecasts from today to the next 8 days. And so severe weather especially can be very difficult to forecast. Beyond the next 8 days, you might be setting up to a general pattern the next couple of weeks that could be favorable, but certainly specific locations is very, very challenging beyond a week or so. Now, you've heard, though, from several experts already on the call that we're expecting a busy tropical storm season, tropical cyclone season. So that can certainly lead to a busier, some more tornadoes, certainly this summer. And we'll just certainly have to wait and see for how the things play out in terms of landfalling hurricanes and tropical storms, and then also have favorability for tornadoes in those particular systems and how favorable that environment might be. But certainly the potential is there to continue to add to these numbers. And having said that, we've been very busy. We are entering now into June. It does certainly appear that the extreme busyness of the high-end events that we've been seeing for the past several weeks is going to come to an end with this last system that we just had over the past Memorial Day weekend. And not to mean that we're not going to see a lot of busy weather over the summer. There is a lot of active severe weather over the summer. That's just climatology. But these bigger high-end tornado outbreak days that are covering large states, those are typically in April and May and in the late fall and in early or late fall and maybe sometimes in the winter as well. So let's get right into here. This is our website here. There's a web link there. I'm not going to spend a lot of time here. I don't have a lot of time. Go to the next slide, please. So what we do here at SPC is we're forecasting severe weather. And by that, I mean tornado, hail, or wind. Now for impacts, we're talking about the significant severe weather. That's EF2+, 2+ inch diameter hail, and 75 mile per hour winds are greater. That's really where you're seeing the most significant impacts occurring among society to both life and property. Now, obviously a question might be, what about lightning? Well, lightning is not one of the severe thunderstorm definition. You can click one for me. But there are about 60 deaths per year from lightning and about $1 billion in insurance losses from lightning. And in fact, flash floods are the #1 severe storm killer, about 90 fatalities per year. Tornadoes is about 70 fatalities per year on average. Next slide, please. So here's going to be some climatology of each of the individual hazards. And I'm not going to spend a lot of time. They're just loops. They're going to see kind of how things evolve. You might expect, things in the Gulf Coast during the winter, and then they kind of spread inland as the moisture spreads inland throughout the year. These are all available online. The links are right here. There's a QR code right there. And so you can look at them and feel free to contact me. We can talk about them more if you'd like. Next slide, please. Here's the wind gust. And so as you might expect, things build up from the southeast. They're really peaking in the May, June, and July timeframe. For summer weather, wind is probably the biggest story because there's just a lot of wind damage across the country and a lot of potential as you get really warm, humid environments develop. The tornado potential goes down, but the wind potential goes up. You might have long multi-state complexes that cross areas. And the worst of the worst are what called derechos. Now, these are very difficult to forecast, and they're fast-moving thunderstorm complexes that can really leave widespread swaths of wind across multi-regional areas. It really can stress your response efforts. And my guess is for you guys, derechos are the biggest in terms of costly and timeliness, and just impact-wise can be very challenging. And they're often followed by intense heat. So you might lose power over large areas, and then you come in with heat afterwards, and now you're dealing with the heat-related problems that might occur. I do want to just briefly say that mobile homes, we all know that mobile homes aren't good in tornadoes, but they're absolutely terrible in wind as well. It doesn't take much wind to topple a mobile home and to cause threat to life and to your life and to your family's life. So please, let's keep messaging that it's not just tornadoes, it's severe thunderstorms. Let's get out of the mobile homes and get to a better safe place for shelter. Next slide, please. Next here is hail. Hail is very similar to wind. It's really, as we peak into the summertime, things kind of shift up into the central plains. Over the next month or two, things will kind of peak during that time, and then things kind of tail off as we get into August. Really, as we get next couple months, the challenges are going to be 2+ inch hail over some areas, especially the central plains, that are the most common areas for that. Next slide. I'm almost done here, Ben. Just 1 second.
Okay.
Here's the tornado. Again, tornadoes they really peak April and May. As we get into June and July, things start to kind of calm down a little bit more on the tornadoes. They really focus more on the central plains and become a little less common in other areas. Next slide, please. And this is just a quick slide to show our categorical outlooks. And this is all available on our website. And they go from level 1 to level 5 in terms of severity. 1 is isolated. 5 is there's going to be an outbreak potential. Next slide, please. And this is just some climatology. So these are all the different categories from the thunderstorm risk all the way up to high risk in the bottom right. It gets you an idea of where within the country it gets these particular areas. And I think this is my last slide on the next one. And this is kind of a good summary slide here. This is where we issue the watches. Now, a good heads up, if you're in a slight risk, expect a probable watch that day, at least a 50% chance of a watch. If you're in a marginal risk, you might not get a watch that day. In fact, it's probably unlikely. And so you can certainly see here where the corridors of most favorable risk areas are. For watches, we're looking for organized severe weather. That's the last slide. Next slide, please. This is my thank you. Thank you so much. And I'm always available at any time to talk more, to chat about the data or about the summer as well.
Thank you very much, Matt. And I'm sorry we had to kind of rush through things, but still trying to keep us on schedule to hit that 4 p.m. cutoff time. But well, if anybody has a question, we'll take one. If there's any out there, I don't see any at the moment. But if there aren't any, then we will certainly thank you for all the information. I did see hail-related news that we got our first DVD-sized hail warning yesterday in Texas. So that's a new one. Hail's been a big threat this year.
Absolutely.
All right. So thank you very much. And now we will go over to Angelina Rose with the Energy Information Administration, or EIA, who's going to talk to us about the short-term energy outlook and that relates, of course, to fuels, what summer fuels outlook is. So without ado, thank you, Angelina.
Thank you. And there's actually a line of thunderstorms rolling through the DC metro area right now. So it's very suitable, and hopefully I don't lose and then ironically lose connection. But good afternoon, and thank you for having me here today. I'm going to be sharing EIA's views on summer fuels. Next slide, please. So we have a lot of material to get through, but before we get started, I just wanted to say a few words about EIA. Hopefully all of you are familiar with EIA and its statistics and analysis. For those of you who aren't, EIA is an independent and impartial statistical organization within the Department of Energy. We are completely policy neutral. Our work is to increase transparency and support the public understanding of important energy issues. Next slide, please. So today I'll mostly be sharing our forecast as published in our short-term energy outlook, or as we refer to it as our STEO, which was released earlier this month. STEO is a monthly publication, so the next release will be June 11th. I'm going to be going through our forecast for gasoline and diesel fuel for the summer driving season, which is defined as April through September. I'm also going to be going over our forecast for electricity expenditures for the summer. For electricity markets, we define summer as June through August. Lastly, I'm going to be pointing out some tools we have that might be helpful for you in assessing electricity markets, particularly after significant weather events or other events. They're kind of really cool, and I just want to make sure you all are aware of them. Next slide. So the bottom line up front, despite higher crude oil prices, we expect that retail gasoline prices will be about the same level as they were last summer, and that diesel will be even lower. Gasoline consumption is expected to increase this summer, but is going to remain below pre-pandemic levels. Electricity consumption is higher with forecasts of warmer weather, but lower electricity prices offset this higher consumption somewhat. So expenditures on a national level, we're expecting the average residential electricity bill to only increase by about 3%. Next slide. And you can do next slide again. So I'm going to start with the transportation. Liquid fuels. Before we get into our forecast, I wanted to talk about some ways that weather, particularly hurricanes, which we just heard a lot about, affect the petroleum market. So what you're seeing on this graph is the monthly U.S. crude oil production from January 2000 through February 2024. Hurricanes primarily affect petroleum markets by disrupting crude oil production and refinery operations. Offshore crude oil in the United States is concentrated in the Gulf of Mexico and can be significantly impacted by inclement weather. So you can see in the federal Gulf of Mexico offshore is shown in blue here. You can see that it's increasingly making up a smaller share of our total US crude oil production. But in 2023, it made up about 14%. And you can see in the callouts on this graph, which in red that show major storms, that there's significant impacts during hurricanes on this production, which has an overall is noticeable at the national level. Offshore oil and natural gas floating production units contend with some of the most severe hazards associated with hurricanes. And tropical storage, they must have emergency procedures to evacuate non-essential personnel, as well as temporarily halt production, which you're seeing in the storms identified on this slide. Next slide, please. So what this is showing is a map of the Gulf Coast states where most of the U.S. refinery complex for petroleum is located. Refining of crude oil is also affected by hurricanes in certain parts of the Gulf Coast. Refineries along the Texas and Louisiana Gulf Coast account for almost half of the U.S. refining capacity. These facilities risk flooding or power outages associated with major storms or hurricanes. So like offshore floating production facilities, many refinery operators will evacuate non-essential personnel and temporarily stop production if they believe severe weather might injure employees or damage their facilities. While the path of a single hurricane or major storm is unlikely to affect more than a single cluster of refineries, because of the total volume of refining capacity in the Gulf Coast region, more than 1 million barrels per day of capacity could be temporarily taken offline in anticipation of a major storm. So refineries that sustain major damage or flooding because of the storm may be taken offline for even longer, and major storms do cost a lot to repair. So EIA does consider some level of weather disruption when we're putting together our summer forecast. Next slide. So now we're going to get into that forecast, starting with our forecast for the Brent crude oil price, which you can see in this chart in the blue line, and I've called out the summer driving season in those, the average for the summer driving season, and those are the brown lines. Crude oil is a significant contributor to what we pay for a gallon of transportation liquid fuels. So thinking of crude oil prices, after global inventories declined slightly, so this is global inventories of petroleum, declined slightly in the first 2 quarters of 2024 and contributed to rising oil prices, EIA expects global crude oil inventories to remain fairly balanced during the summer months. This limits the upward pressure on oil prices. We're expecting Brent crude oil prices to average about $90 this summer, which is about $7 higher than last summer. Thinking of the US benchmark for crude oil, West Texas Intermediate, we're expecting that to average $85 this summer. Because the market is in such balance, there is significant price uncertainty because of the relative balance of the markets through the end of the year, as a loss of supply for unplanned production disruptions could cause oil prices to rise above forecast levels. Next slide, please. So what this slide is showing is gasoline prices. So gasoline prices are determined by crude oil prices, refinery production costs, distribution, marketing costs, as well as taxes. So what you're seeing on this slide, and I'll show one for diesel fuel in a couple slides, is the gasoline price over the summer, with the summer months called out in the black bars on the left-hand graph. So that's the blue is gasoline line, as well as how the components, what the components of change on an annual basis are. So summer retail gasoline prices are expected to be close to last year's levels, which you can see on the left. On the right, you can see that the rise in crude oil prices that I just discussed are offset by falling refinery margins, which you can see particularly in the yellow area of the right-hand graph. Next slide. So these factors can differ by region and state within the United States, and local supply and demand conditions matter. So what this slide is showing is looking for at the summer, looking at last summer on the left by region, and on the right side of the graph for this summer. Retail gasoline price spreads between the East Coast and the Gulf Coast. And again, we're looking at the Gulf Coast because there's over half of our refining infrastructure is there. It varies seasonally and are responsive to these local supply and demand conditions. In January, the East Coast premium to the Gulf Coast was 30% higher than the 5-year average. And we forecast that the premium will decline from the January high to average about 14% over the 5-year average for the remainder of 2024. The highest premium occurring both in May and June. Similarly, West Coast retail gasoline prices are higher than those in the rest of the country, which you can see in the red bar, and can develop wide price premiums depending, again, on local supply and demand conditions. As with the East Coast, the West Coast premium to the Gulf Coast has been increasing over the last 5 years. In April, the West Coast retail price premium to the Gulf Coast was $1.57 per gallon, which is 42% higher than the 5-year average for that month. And we estimate that that price premium will decrease, resulting in an annual average price premium of the West Coast fuel that is 21% above the 5-year average for the remainder of 2024. Next slide. So this is just showing diesel prices. I showed the gasoline version of this graph slide 2 slides ago. So similar to gasoline prices, but to a more pronounced degree, increases in the Brent crude oil price are offset by declining margins, which lead to overall declining prices for diesel fuel this summer compared to last summer. Next slide, please. So we're going to be moving on to electricity. Next slide, please. So summer electricity consumption depends on the weather. Nearly 90% of US households use air conditioners, and monthly residential electricity consumption across many regions of the United States is greatest in the June, July, August timeframe. Customers in the southern states across the Gulf Coast generally consume the most electricity per household because of the hot and humid summer weather. Customers in states with milder weather, like along the Pacific Coast or in New England, regions where air conditioning is maybe less common or used less often, generally consume less electricity in the summer compared with other regions. What you're seeing on this chart is for 2024, for each month, we're expecting more cooling degree days, so higher cooling degree days than last summer. And these forecasts, EIA is not in the business of forecasting weather. We leave that to our colleagues over in NOAA. So this is based off of their forecast. So you can see for this summer, we're higher than last summer in terms of warmer weather, days of warmer weather, as well as we're higher than the 5-year average. The weather remains a major source of uncertainty in our forecasts for residential electricity bills. If temperatures end up much higher than expected, households will face higher electricity bills, particularly in the southern states. Next slide, please. So this slide is showing 3 different things. On the left, you can see the consumption, average consumption per household in the summer months. I'm just making my screen a little bit bigger. You can see the electricity price in the center, as well as the average residential electricity bill. And the colored segments of those lines are showing the summer months within that line graph. So residential electricity customers' monthly bills are based on both the amount of electricity consumed and their retail electricity price. So the higher cooling degree days that we just saw results in higher electricity consumption this summer. And that combined with lower US residential rates lead to expenditures that are only slightly more, about 3% on average, over last year's electricity bills. We expect that the typical US residential customer would use about 1,100 kilowatt hours of electricity each month, June, July, and August, with a little bit, which is a little bit higher than last summer. Most areas increase about 4 to 9% over last year's levels in terms of consumption, although the West South Central Census Division, which is Arkansas, Louisiana, Oklahoma, Texas, will use about 3% less. We're forecasting them to use about 3% less electricity because of the hot summer last year. Next slide, please. I just have a few more slides. So lower forecast summer electricity prices are an artifact or reflect lower costs from previous years. So as many of you know, in many areas of the country, state regulators approve the rates that electric utilities may charge to customers based on recently incurred costs. So changes in costs can take time to be incorporated into retail electricity rates. In other areas of the country, residential households can choose their electricity suppliers, allowing them the flexibility to shop around for lower rates. The amount of time between when the costs are incurred and when those costs are reflected in retail electricity prices can vary from a few months to several years. So average wholesale power prices, which are an indicator of generation costs, were trending higher in 2021 and 2022 in response to rising natural gas prices. But natural gas prices, as well as wholesale electricity costs, have since trended lower. In most states, customer charges for transmission and distribution on electricity bills are set by state regulators and typically reflect the costs incurred over many years. Costs for delivering electricity to end-use customers have also risen as new infrastructure is added to the grid or existing wires are replaced, and these costs have been one of the major drivers in the increase in retail electricity prices in recent years. Next slide. So on average, we forecast that the U.S. residential electricity customer will pay about $5 more this summer than on their electricity bills. And of course, this varies by regions. Customers in the West, South, Central states, again, Arkansas, Louisiana, Oklahoma, and Texas, could pay about $10 less on their bills than last summer, whereas customers in the Pacific region may pay about $12 more as a result of higher electricity prices. Next slide. So that's, and the next slide. So I was just going to walk you all through some, just very quickly. This is all on our website, and I've included links for you to kind of explore. We have a couple of what I think are really cool electricity market tools. We recently launched a wholesale electricity market portal that can help our users examine and access electricity market data from 7 major grid operators, so independent system operators or regional transmission organizations. We're getting the data directly from their website, so it's not an EIA survey. We're pulling this all into a single spot just to make it more convenient and for to help people analyze what's going on in their markets. And you can see all the data that are available. Next slide. What's kind of cool is they also have, we have this by different regions. So you can look at your own, ISO or RTO region to see, what the generation is fuel by source or the forecast or demand for electricity. And you can also bulk download this formatted data. So this is our wholesale electricity market dashboard, recently launched. Next slide, please. We also have an hourly electric grid monitor, which is something I think is really cool. As the name suggests, it looks at the electric grid on an hourly basis, looks at demand and demand by subregion, net generation, generation by source. This is something that's kind of interesting to look at during, in the midst of either people having issues because of a storm or recovery after a storm, or even we looked at it and I think released today an energy article on looking at the effect of the solar eclipse had as it moved through different areas on solar generation. You can kind of see that level of granularity. So it's pretty cool. So with that, I am finished. Thank you all for having me here. My next slide is just, that will be a part of the deck, is just a bunch of resources that you may find of interest.
Thank you very much, Angelina. I appreciate you jamming all that information in as quickly as you did. It's a whole lot to take in, but the short-term energy outlook usually is. And I think, if anything, that helps us get an idea of just prices and that general awareness, but also just what EIA does. I try to catch the This Week in Petroleum or the another article. Often I get asked, how did I learn so much about energy? And a lot of that is because I read, and it's reading the articles that EIA puts out on a regular basis, and the charts and graphs. So that is, in the absence of any other questions, I'm going to take the moderator privilege and say that one of the questions I had is, what could states provide EIA with feedback on data availability or needs, or are there trainings that EIA has that might help us understand this data a little better?
Sure. So I would encourage states, there's a couple of ways to provide feedback, formal and informal. I would encourage states, we have a part of our website called the State Energy Portals, which we kind of summarize what's going on in a particular state. Certainly, I mean, that is a great starting point for states to take a look at, to see, it's under geography on our website on the main navigation bar, to see, like how are we characterizing things? What do you think we're missing? And if you've come across something that you think we're missing or we should be doing better, and I know a lot of times it might seem like, oh, this won't work, but like I would really encourage you, at the bottom of our website, there's a contact us. and if you clicked on the contact us, kind of source out like, well, do you want to contact somebody about geography or a different fuel, and really reach out to people. There are humans on the other end of those email addresses that are very responsive and are happy to be responsive. We also do have a YouTube channel, like the wholesale electricity market tool that I just showed. There's I think it's about a half hour or so training video about how to use that or the different features that we put together. There's, for our more complex tools, we have resources like that. And lastly, what I would also say for those of you who have particular interest in the data that we're providing or could provide, all our data that we collect over our survey goes through a Federal Register notice process. If you Google, and this is the only really elegant way to do it, if you Google EIA and Federal Register notice, you'll come up to EIA's page within the Federal Register notice. And so you'll see, like, even about a week or so ago, or maybe even this week, we put out a Federal Register notice for changes we want to do in the residential energy consumption survey. And so we seek public comment. There's usually a 60-day window about, like, yeah, we're thinking of launching this survey, or we're thinking, and there's a lot of really interesting new surveys coming out of EIA. And I would really encourage you all to kind of be a part of that public process and provide that feedback.
Excellent. Thank you very much. And I do have another question. Ed O'Brien in Louisiana says, do you have a timeline for when the reserves for oil and gas will be produced? The last release date was December 30th of 22, and the December 29th of 23 release didn't happen.
That is I will look, I do not know. I mean, I know it usually is released with data. Here, hold on a second. We released year-end 2022 on this past April. I'll put a link in the report. There is usually a lot for some of our data. There are, I mean, obviously this is year-end 2022. There's a lag in terms of how we collect the data or gather the data. We have more current data, like we have hourly data, but for this data series, it's longer. But I will I put it in the webinar chat. And forgive me if this is what you're looking at and you're just wondering if we're going to get when the 2023 data are going to come out. But yeah, that's the most current we have right now and is as of the end of last month.
Okay. Well, thank you very much. And we appreciate you taking the time out of your day to explain all this great data to us, and certainly everybody. And if it's like us, if somebody does feedback on the website, we have to answer it. So that's usually a good way, even though people don't think there are live people behind there doing it. It gets usually directed, and we have to do it pretty often. And EIA has been really good about some feedback I've provided in the past. So thank you very much.
Great. Thank you. And thank you for having me.
And with that, now that we've heard about electricity prices from EIA, now let's go into the summer reliability assessment and see how we're going to get that electricity. And for that, we've got Stephen Cotarillo.
Thanks, Ben. I appreciate it. And thank you, everyone here today, for listening. So NERC is the North American Electric Reliability Corporation, and we're an independent part of electricity monitoring throughout the North American footprint, so the United States, Canada, and a small part of Mexico. And so we release a report every summer. And so it's an operational assessment that details what impacts might happen over summer, what are the types of things that we're seeing at areas bringing in new resources, what demand levels might look like, and how it ties into weather, right? So for this year, I just wanted to give a summary for everyone for NERC's 2024 Summer Reliability Assessment, which finds that potential extreme temperatures across much of North America could be a cause for concern for grid reliability this summer. But I really want to leave you with 3 key messages from the report and throughout this presentation, and things to keep an eye on coming up for this summer. First is wide area heat. Expected wide area heat events may drive above normal electricity demand, which can strain resources and the transmission network. Second, surging load growth is being helped. The demand is being helped by solar resource additions that are coming in. So as demand grows in many areas at a rapid pace and strains parts of the system, record amounts of solar PV resources are being added, and a lot have been added since last summer. And so capacity is keeping up with the rising summer demand for the most part. And then lastly, energy risk. So while all areas have adequate resources for peak energy demand, Energy risks are growing in several areas when solar, wind, and hydro output could be low due to cloud cover, the wind is not blowing as strong, or drought conditions throughout the North American footprint. So on our next slide, we'll get started here with some key takeaways from this year's report, and just want to highlight this risk area map here, which shows the areas that we have indicated for elevated risk. So this is a potential for insufficient operating reserves in extreme conditions. So just a preamble here, the North American footprint shows to be good for normal conditions, but if we do see those extreme temperatures, then there could be cause for concern if a wide area heat event affects North America. But consistent with last year, as I mentioned, all areas are assessed to have adequate supply for normal peak load and conditions. And a large part of North America remains at risk for supply shortfalls during heat waves and extreme summer conditions that can affect generation, wind output, or transmission systems. Demand growth in some areas is contributing to adequacy risks for resources and transmission. And then lastly, there are supply chain issues which have affected resource additions coming in, which has added less capacity to the grid for the summer than projected since our last long-term report. And projects that benefit the summer reliability should be carefully monitored going into the season. And so here I just want to highlight the different things that we use for our report. We do on-peak reserve margin analysis, we have operational risk analysis, and probabilistic energy metrics. So we're looking at a variety of different tools to measure and see how each area is doing for this upcoming summer and within the footprint, and also how the impacts might spill over into other areas in the neighboring parts. So we take the regular demand that comes in, we take the expected conditions, but then we also take it another level. We look at 90-10 conditions that might include those extreme weather events. And so we would see what high generator outages or low wind and solar scenarios might do to the grid. We also look at if there's a wide area heat event, what transfers might look like. And so each area goes through their own set of criteria that they've set for the summer going in. So on the next slide, we can move forward with a little more specifics on weather related things. So a lot of the colleagues that have spoken today already have already given us kind of the theme that summer might be hotter than we expect for normal conditions, but operators should prepare for another difficult summer. And so as we've heard from others today, weather services in the US and Canada are warning that challenging heat conditions could be in store for North America again this summer. So this underscores the need for operators of the grid to be more prepared for above normal demand and resource challenges that may impact the grid this summer. The North American drought monitoring shows improved conditions for much of North America, but moderate to extreme drought persists across the western half of Canada and the US Southwest. And drought can affect summer resource adequacy and bulk power system reliability by increasing the temperatures, elevating wildfire risk, and may affect hydro output in the areas affected by drought. So last summer brought record temperatures, extended heat waves, and wildfires to large parts of North America, and operators were faced with significant challenges, but were highly effective in maintaining reliability. Additionally, we would say that government officials in many parts of North America used public appeals when necessary to help lower customer demand during periods of strained supplies. The grid operators should review lessons and experience from the prior summer and incorporate these into the planning of seasonal operations for this summer as well. And so if we look at our next slide, we'll look at what demand has done since last year. And this is very correlated to temperatures, right? So as temperatures rise, you can expect more electricity usage. So it's important to know what demand does from year to year. So demand is growing in most areas, and with some areas receiving large increases in peak demand forecasts, and they can face challenges in meeting reserves should temperatures go much above normal. So in the middle of the country, ERCOT and SPP, the increases in peak demand forecasts are among the highest, and they build on similar growth since the prior year. And so drivers for this demand growth in areas can vary and may include demographic or economic activity changes. But a huge thing we're seeing is new demand centers and data centers and cryptocurrency mining facilities that also contribute to higher demand forecasts here. And so in Texas, a large part of these loads are actually participating in demand side management programs, which can help offset their impact so they can be called upon to reduce their load during times of need. And so with that, we've moved to our next slide, which would be reserve margin changes since last year. So tracking and theming what temperatures were like, what was the operating experience in reality, and then looking at what our predictions are for this season, how are the areas looking in a normal case. So resource additions here in many assessment areas that were identified as at risk in last year's summer report have actually had resource additions that outpace the rising demand forecast. And this is reflected in higher reserve margins, which is great news, right? So notable here, SPP has additional wind resources and capacity from switchable generators that previously were being offered into neighboring areas. So using their resources to help their footprint. Ontario has fewer nuclear units out for scheduled refurbishments this summer and has increased firm imports from Quebec. So this can help a lot of the northeastern parts of the United States with transfers coming into the US. Cirque Central is also more firm imports committed for the upcoming summer and has new gas-fired and solar resources committed for this upcoming season. And then the US Western Interconnection has 1.6 gigawatts of batteries, which were installed at the end of 2023, and another 3 gigawatts are in the process of connecting over this summer. So this will help during times when solar is dropping off in the evening hours, or we also have just sun drought where the cloud cover is a long time. So the solar resources can help replace the solar and wind output when they've diminished to a lower level. And then also California's hydro outlook has improved after much winter precipitation and snowpack has materialized in better hydro levels. And so now on our next slide, we'll look at solar and battery resources throughout the footprint. And so continuing with that last comment I made about California adding a ton of batteries, there's been a sizable addition of solar resources in general as well. The 25 gigawatts in new solar capacity is connected to the bulk power system when the prior year saw around 19 gigawatts of additions. So this is nameplate capacity. It's important to note that this is not what's being contributed on peak, but this just shows the magnitude of solar coming in and helping the rising demand forecast and helping offset that and helping keep areas in good shape for the peak demand conditions. So it's important to keep in mind how extreme temperatures can impact the bulk power system. And as we've seen increasing share of solar, we are becoming more dependent on solar's energy usage. So if we have less of the sun out, then we need to make sure we have other resources as well to help replace the conditions as well. And so on our next slide, I'll just do some highlights of the summer assessment. So unexpected tripping of solar PV battery resources can also cause disturbances. It's an ongoing concern throughout the grid. So we want to make sure that we're keeping an eye out for any of these disturbances and understanding lessons learned from these and making sure we exercise the messaging throughout. Coordination between electric and natural gas operators is needed to help ensure fuel delivery, reliable fuel delivery for generation. So ensuring that their two industries are coordinating together, making sure that the communication lines are open. And so if there is any issues between the two, that they can notify each other in time. And then supply chain and construction delays are also affecting new resources and transmission projects coming into the grid, and they can help exacerbate operating challenges throughout the season. And so on our next slide, we'll look at some recommendations for the area and what we would like as takeaways from our assessment. So operators in risk areas should review plans for resolving supply shortfalls and implement conservative operating procedures well in advance of approaching weather systems. Operators of load-serving entities can develop and coordinate procedures for demand-side management to help with load reduction. And generator owners with solar PV can implement NERC's inverter-based resource performance issues alert. And this will help adjust settings to support disturbance ride-through and in consultation with the manufacturer recommendations. And lastly, state regulators and industry should prepare for managing emergent requests for air quality restriction waivers. So should specific forms of generation be needed to meet demand and help serve the load, please looking at the waivers that would be required for air quality and seeing if we can keep those generators running if needed. And so with that, I believe that's it for my presentation. So I'm happy to answer any questions that the group or our moderator may have.
Sure. Thank you so much, Stephen. That was a great briefing. And I'll start with the first question while anybody else is putting a question in the Q&A box. One of the ones that we wondered was, what recommendations would you have for state policymakers to maintain their own awareness of prolonged heat patterns and impacts to the grid?
Yeah, that's a great question, Ben. So for maintaining awareness, I think it'd be making sure you stay tuned to any updates you may receive from grid operators and utilities about potential energy shortfalls that may be upcoming, and then proactively work to plan for any energy emergency situations. And I believe this would help with maintaining situational awareness for a prolonged heat spell. So it'd be good to make sure you're staying plugged into those sources.
So don't have any others, but what are some other recommendations you might have for the energy offices to help increase reliability and resilience? Because we are working on a lot of different projects and funds coming our way, and working on grid resiliency. And I know we've hired a grid resilience manager to just help manage all the projects related to that funding. So what are some recommendations that you, given the supply chain, what are some things that we could do to help make states more resilient?
Yeah, sure. Yeah, similarly, like working with utilities and grid operators to help prepare and posture the development of your state energy security plans. I think that's important to keep prepared in that way. And we hope we never have to deal with the worst day, but having a proactive plan that helps identify what risk areas an area may have, prioritize restoration solutions, and then coordinating emergency planning in advance will help keep the state more resilient and more reliable for anything that may come our way in this summer or summers ahead.
Excellent. Thank you so much, Stephen, and I appreciate your time. And again, yet another one of packing a lot of information in a short time period. So I appreciate the compressed timeline for it, because the assessment's always a good thing, but you boiled it down to what was good and what to take away. And if you do have the time, read the full report. It's usually a good way to learn about it and how well NERC usually writes a great report also. So it's, again, if you're trying to learn what's going on there, take the time to read it. You may not be able to read it all at one sitting, but it's a good background, a good way to understand what's going on with the grid. So thank you very much, Stephen. And with that, we will turn to our next one. Now that we know one of the things that could impact all that reliability is the fire season. And so we'll turn it over to Jim Wallman.
All right, thanks, Ben. So I'm just going to go ahead and talk about our current fire season outlook. Really, it's just going to be through June through August. Some ideas for September, as we'll be coming out with our new outlook on the first of the month. So starting the next slide, just to give an overview of our program here, Predictive Services, established almost 25 years ago, and we are staffed by meteorologists such as myself, fire analysts, and intel coordinators and officers. Every geographic area, which is, you see that image on the right, there's 10 geographic areas. Each one of those has its own predictive service unit and issues their own forecasts independently, but we have a lot of collaboration and coordination between those offices and here at the national level as well. And then we take those GAC level products and integrate them into a national product. Next slide. So for our monthly and seasonal outlooks, how do we put it together? How do we create them? We look at current conditions, such as snowpack and recent precipitation. Drought and soil moisture is also factored into that. And from that, we can also look at fuel loading, the phenology, which is the state of the fuels, especially your fine fuels, your grasses and brush. Are they cured? Are they in green up? Or, for the much of the east is, are you on leaf on or leaf off with the hardwoods? And we also look at the moisture content, not only of the living vegetation, but also of the dead vegetation, the needles on the ground, the logs and things like that. And then we also try to analyze like the fire season timing. When is it going to start? Is it going to be slower to start? Is it going to be delayed? Or is it going to last longer into the season? That's then typical. So that's something we look at as well. And then we look at the weather and climate outlooks. We work very closely with the Climate Prediction Center. You had Matt Rosencrantz on earlier, kind of going through that. I'll kind of highlight it again a little bit, kind of how that kind of fills in for the national outlooks here. We also have some in-house expertise as well. And then we look at the global circulations. Matt went into a bit about NASEO. I'll briefly touch on it here as well. But we also look at some of the other things, such as the Madden-Julian oscillation, which is like the tropical convection. How does that impact on a shorter time scale, especially in that 2 to 4 week period. How could that impact the forecast? And then we look at, what's going to happen for the next 1 to 4 months in as far as fire. So, and then when we put those 1 to 4 months out, it's just a blend of all that to produce either normal, above, or below normal significant fire potential. Next slide. So I'm going to kind of backtrack and kind of look at what happened. And so this is like February to April precipitation and temperature from the Prism Group at Oregon State. Here on the left, it was fairly wet due to El Nino across the southwestern U.S., much of California through the Great Basin and into the southwest, especially west of the Continental Divide. That's really important for a couple reasons. One, not only does it really help to add moisture to the larger fuels, your dead logs, but it also provides a lot of potential for grass growth, fine field growth, and also the bigger growth in your shrubs because they're flush with moisture. On the right, temperatures were generally below normal across much of the, not below, above normal across much of the upper Midwest. That was a concern for a long time for us. However, that has started to be alleviated recently. Next slide. So I'm just going to take a look back at the snowpack on April 30th. This is a little bit beyond the peak, but it gives us a pretty good idea. Is the snow come off faster? What's going on? And at that point in time, the snowpack was below normal across much of the northern Rockies, from Washington. Then you go into much of Idaho and Montana was below normal, but the Great Basin, California, the Sierra, the Southwest was generally near to above normal this winter. Although it did come off a little bit earlier in New Mexico, but it's not that much earlier, as they tend to lose their snowpack quite a bit earlier than everywhere else. So next slide. So kind of looking what we've had so far this month, one of the big things, like I mentioned, was those really above normal temperatures, the low snowpack that was present over the Midwest, really had us worried about Minnesota, Wisconsin, the Upper Peninsula, and Michigan, but they've been really wet over the last month. And with May being one of their wettest months as well, that's really alleviated our concerns there. But out west, it's kind of going into typical dry season in the Southwest. We have been a little bit drier than normal across much of the Great Basin. The concern there is we've had a lot of grass growth, and we're starting to kill those fuels out maybe a little bit earlier than normal. So go to the next slide. So taking that all into account, Matt showed a version of this earlier. I think this is just taken 1 week later from what he showed, and really not much change, just highlighting the Southwest. A lot of that's been there from the weak monsoon last year into portions of West Texas. And the other areas that we're also kind of noted up there in Washington, northern Idaho, western Montana are also a concern for our outlook. However, it has been a little bit wet up north over the past month, so that's kind of helped alleviate some concern, but not all of it. We got a next slide. So as Matt also mentioned, is it El Nino or La Nina? How does that impact the forecast? We are coming out of a strong El Nino, which brought all that precipitation to the southwestern U.S. Now we're in that transition. As Matt said, we're now in neutral conditions. Yeah, there's a La Nina watch out and expected to have a rapid transition to La Nina this summer. That's 69% chance. Now, what that also does, especially when we get in this time of year, is how does that impact the monsoon? Typically, El Nino correlates to a weaker than normal monsoon for the Southwest, and La Nina is a little bit wetter than normal. This year, with that transition, the concern is it's going to be a bit weaker than normal because we have been in that El Nino transition. It seems like that spring kind of temperatures out of the Southwest can have an impact on the monsoon. So we're having it, at least now, in our shop, we're looking at a delayed monsoon and probably weaker, which is consistent with what this Climate Prediction Center is looking at as well. So next slide. And just like Matt showed earlier, that June through August outlook from them, this is actually the older version about a month ago, but it's very similar, really dry across much of the west, especially in the monsoon region, and temperatures generally above normal for much of the west as well. So next slide. So how does that impact our outlook? Well, this is as of, the first of the month, 1st of May. Those concerns over northern Minnesota, Wisconsin, Michigan have been alleviated. We're no longer expecting above normal there due to that wetness. So we think that that concern is going to go away when we put our new outlook out on the 1st. However, Central and South Florida, where there has been some drought developing, their fuels are drier than normal, so are near records, and we're expecting their fire potential to be above normal, especially for the southern half of the peninsula. I was on a call last week, and their fuels have been, they're mentioning how dry their fuels are. Just kind of surprised that they have been relatively quiet so far, but they're not expecting that to continue, especially to start before the wet season, get any isolated storms that could have some lightning ignited fires. As far as California, here's the good news. It looks like because of that wet winter, the fuel moistures are quite a bit higher than they are this time of year, and a bit more onshore flow is expected to continue in June. That they're going to have a slower than normal start to the fire season, especially for much of the state and the higher elevations. Maybe some of the lower elevations in the Central Valley, kind of not where it's irrigated with all the farming there, but on the edges, they could have a normal start with a bunch of grass fires there as they start to cure right now. But really not a major concern in California, at least June and possibly July. But the Southwest and now portions of the Southern Great Basin, kind of outside of Vegas, maybe more of Southern Nevada, we're expecting to have above normal potential there. Really, there's a lot of fuel, fine fuel, a lot of grasses around the Phoenix area down to Tucson. So with that above normal fuel loading, they could have above normal potential with their typical early season, like before their monsoon really starts. Thunderstorms could start a bunch of ignitions, and it's also a bit drier there in New Mexico due to the drought. So that's a concern there as well in far west Texas. Now, Hawaii was really wet also in May for much of the state. So they've had another round of growth for grasses and fine fuels. But so right now, we don't think June is going to be above normal anymore. We think that's going to be below normal. But when those fuels dry out, as we get further along in the dry season for Hawaii, that can become a big concern over the summer. So next slide. So for July, now our concern is really going to shift more in the southwest to more of New Mexico. We do expect a little bit delayed monsoon, but consistent with what the Climate Prediction Center was showing. Probably that dryness, that weaker monsoon will be focused more over New Mexico than rather Arizona. So that's why we're kind of highlighting much of New Mexico in July. And then the Great Basin, we could see some areas of above normal maybe hanging on in the Southern Great Basin, Southern Nevada, Southern Utah. But with all the grass growth in the Northern Great Basin, Northern Western Nevada, Southern Utah, Southeast Oregon, we're expecting that abundant fine fuels out there, the abundant grasses, as they cure out over the next month to be available to burn. We had a big lightning event here in Boise last night, and we actually had some fires start where some of the grasses are already starting to cure. And this is it's a bit early, but it's just showing us that we haven't seen that in the last couple of years here. And so that's a concern that we will, when they dry out, we do have that potential. And that's kind of like one of the indicators around here. So this is starting to look pretty good, feeling fairly confident in that area. And then also portions of Western Washington. Snowpack in the Olympics was really low, and portions of the northern Cascades as well. So we're expecting above normal potential there. Now, remember, this is relative to normal for each area. So the Great Basin, if we're saying above normal July and August, you expect a lot of fires and a lot of acreage. Western Washington, we don't get a lot of big fires there. So traditionally, we might get, maybe 2 fires, which are large enough to maybe have, go 2, 3, 4, 500 acres. and that's a big fire for them because it's a bit unusual. So that's what I mean. It's relative to the area. Now, California, again, a slower start to the season. This is going to be more weighted to the first half of July. And then for Hawaii, we think those fuels will dry out by enough in July to have that above normal potential. And that additional growth will probably just create more concern. Next slide. Then finally, for August, those areas in the Great Basin are going to continue. Also for Hawaii and portions of New Mexico, this may expand here in our next outlook, and then across Northwest Washington as well. And then for Hawaii. Now, some of our concerns now also is as we go into this transition to La Nina, we may have a little bit longer of a season that lasts more into September, and this would be a concern for the Northern Great Basin and potentially also the Northern Rockies, which is really, far eastern Washington, northern Idaho, western Montana, that they could go more into September than normal. As for California, they will go back to normal significant fire potential, which really this is the peak typically for them in California, in the Sierra, Northwest California, that they could be potentially like normally active. So we'll probably see a few large fires there, but nothing like we saw like 2020 or 2021. We were talking about Dixie, Caldor, August Complex, things like that. Now, when we go into September, we are going to be a little bit more concerned as those fuels dry out, probably that, especially in the lower elevations, Central and Southern California could become a concern. So next slide. Just kind of wrapping up here, just to summarize, just really above normal potential for that Midwest is now normal due to the May precipitation. The same thing for Hawaii. Slow start to the season for California due to that precipitation, and the Southwest will have above normal potential for the lower elevations, Southeast Arizona in June with that fine fuel loading, and then much of central New Mexico through August due to that delayed and weak monsoon. And finally, next slide. We're looking at that abundant winter precipitation with all the grasses, the grass growth we've had, on some carryover from last year as well, really focused on the Northern Great Basin, the Southeast Oregon in July and August, and probably into September as well. And then above normal potential for that area, Northwest Washington. And one thing we like to remind everyone is these forecasts are relative to normal for each area. I kind of briefed on that before, like Great Basin, California is different, Northwest, even, out, eastern half of the country, they don't typically see a lot of fires, but every once in a while you do have a large fire there as well. So these forecasts are relative normal and for potential. And so, we could have drier than normal fuels, all these fuels around the Great Basin, like I mentioned, but if we don't have any real critical events, like these lightning events, 1 or 2 lightning events that just really realize that potential, we don't really have the activity that we could potentially have. A good example illustration of that is 2020 California, really dry. It was a very slow season up until mid-August, and then we had that big lightning event, and then it was off to the races. So with that, I'll end there, and pending any questions from y'all. Thank you.
All right, thank you very much, Jim. I appreciate the update. And again, it looks like it's going to be maybe a little bit better, but we're hoping certainly for that. And it's always to get a little bit of good news. And I think, let's see if we have any questions in the chat. Give it a second for folks to do that. And while anybody's getting some questions ready, one of the things I did want to mention that we'll cover at a later meeting for us is there is part of VOAD, the volunteer organizations helping in disasters, does have Team Rubicon, and they actually can provide chainsaw crews that are certified and trained, and they actually can help with vegetative clearing for power companies. So if you've got a small rural co-op or something like that, that's something to check out. We're going to try to get somebody from Team Rubicon to come speak at a later committee meeting. But one of the questions that I wondered is, what are some lessons from previous wildfire seasons and historical forecast, and how those lessons carry forward for you as far as this year's outlook?
We really do look a lot like Matt also mentioned from the Climate Prediction Center, looking at analogs. So we try to look at what previous years have done. And while that below normal snowpack, for example, in the Northwest and Northern Rockies is a concern, the thing is we look back to previous years, this transition from El Nino to La Nina, similar transitions, and their fire activity from those years was not as great as we thought. So that's where I was thinking, okay, that's why we're saying, even though we think the fuels might be drier, we might not get the ignition sources. So we're trying to evolve all the time and try to use that information and get better every time we do one of these forecasts.
Yeah, because it's certainly a very wildfire, I would think, would be one of the hardest things to try to predict, because it's a lot of times, like you said, it's just a matter of where the lightning strikes at the right time in the right place, and trying to yeah, I don't envy that forecast, but I appreciate that you do it.
Yeah, it's hard, but it's good. The thing is with you know, we say, well, you know, humans are hard to predict and we're unpredictable. But when you know you have a lot of people, generally, if the fuels are going to be dry, you can pretty reliably, you know, it's often just mistakes or, you know, someone not realizing it. You get more starts, you could have that more potential. But with lightning, like you said, it's just those events, or even a wind event. Where you have a lot of lightning, but it was a lot of rain with it. So you got a lot of starts, but they're not going anywhere. And then all of a sudden you get, if you get a big dry wind event behind it, then all those fires that are there in the landscape now can really come to life.
It will flare up. Well, I don't have any other questions at this time, but thank you very much for packing all that information in like everyone else and staying within the time frame and to bring us home. And now we have a word from our sponsor, Megan Levy and the CESER office with DOE. Always a friend of the committee and great to have her back, and appreciate everyone. To take the second to thank all our speakers before Megan starts. Really appreciate everyone helping us stay on schedule, but packing all this information in. And with that, I'll turn it over to Megan.
Thanks a lot, Ben, and thanks for your hard work and Audrey's moderating this session. It's can be hard to wrangle all these people and all this great information. We can go right on to the next slide, please, Sarah. Many of you are aware of CESER, and I want to thank you all for sticking around to hear a little bit about the Office of Cybersecurity, Energy Security, Emergency Response. You've heard a lot about upcoming threats for this summer's storm season, and we think about all of them all the time, from cyber to climate to physical to those supply chain risks that we've talked about in the past. On the next slide, we'll talk a little bit about how we work. What is energy risk management? The Department of Energy is a sector risk management agency for the energy sector, and the Federal Coordinating Agency for Emergency Support Function 12, which will likely be called into action this summer. I think that's what we're all hearing. So you can see here on this little diagram, before events, what do? We prepare, we analyze, we think about risk, and we prepare our tools, risk management tools and technology, and develop requirements. Emergencies happen, they always do. And afterwards, it's response and restoration, after action, gap analysis, recovery coordination, continuous improvement. And we're continually coordinating with federal, interagency, regional, state, and industry partners just like you, because we have to. So that's the only way we can do this job and do it really well. On the next slide, talk about just a few of those ways that we share information across the energy sector. We didn't hear from any of the information sharing and analysis centers today, but I hope that many of you got an email from the EISAC that allowed you to sign up for their monthly, on the second Monday of every month. They've got briefings for state officials. It used to be you had to register for each one and get an invitation. On this month's invite, you can register for all of them, and I encourage you to do so. These information sharing and assessment centers are fantastic. And then another key source of information for the CESER team, for our situational awareness team, is the Energy Emergency Assurance Coordinator Program. It's the only MOU of its kind that I know of in the federal complex that allows us to have bidirectional information sharing with every single one of you. Folks in energy offices, regulatory utility commissioners and their staff, governor's offices, emergency management agencies, all are covered in this agreement. And it's really important that we're all colleagues here. We can share relatively classified or controlled unclassified information with each other, leading up to, during, and after an emergency. On the next slide, we'll talk a little bit about more about those energy emergency assurance coordinators. And I think you'll get this deck, so we don't need to talk about it too much, especially because we're up against 5 p.m. here. But if you don't think you have accurate contacts on our list, please reach out to me, reach out to Juan Gomez in the CESER office. It's really important that we have a good list. Our monthly energy analysis brief is coming out in the next week or so. We'll wrap up everything that happened in May, and it was quite an eventful month. As a person who had no power for 4 days last week, I can tell you there were some big, huge storms, a lot of wind, rain, tornadoes. We had it all. And on the next slide, I'll talk a little bit about a tool that we've got, our customizable energy emergency response playbook. Take a look at this. The link's right there in the slide. It's in our State Energy Security Resources hub. You can customize this to anything that you like to monitor on a daily basis, but it's got lots of great links to EIA tools that we heard wonderful things about from Angelina, to your regional transmission operator or independent system operator's website, which it looks like now EIA is pulling in that data for that really cool electricity browser. So check out this playbook. I think we've got one more slide on the playbook if we can go to that. Because it's really a good tool, and it's something that you can make special for your unique state, because we understand that it's not going to be the same in Guam as it might be in Minnesota, and you may be monitoring different data points as you approach storm season, which is appropriate. I'd like to take just a quick second on this next slide to talk about state and territory mutual aid and the Emergency Management Assistance Compact, or EMAC. It's the nation's all-hazard mutual aid system and is ratified by Congress in all 50 states, Guam, DC, Puerto Rico, USVI, and the Northern Marianas Islands. So through EMAC, you can share resources and personnel. And we have worked with our colleagues at the National Emergency Managers Association to create energy-specific mission-ready packages. This is really exciting work. And, check out these links when you get this. Look at all of the folks in liquid fuels, natural gas, electric utility, folks who you can request if you should have unmet needs in the case of a very large and gnarly storm season, as it looks like we might just have this year. I also, on the next slide, we've got a QR code, because who doesn't these days? Scan this to go to all of our SLTT resources, but we've also got a preparedness checklist. I love a checklist. It helps you not forget things. So check it out. Go through this, bookmark that emergency response hub, and review the energy waivers library. All good stuff there. So on these next slides, I'll talk a little bit about stocks. And we all know that gasoline and distillate petroleum is a just-in-time business. And I do appreciate the pricing information that EIA gave us, but we track this for you. This is a status as of May 17th. I think it's always interesting to know sort of what's in the tanks. However, that's just a snapshot in time. And on the next slide, we've got distillate stocks by region. Many of you track these. We've created a liquid fuels risk rubric for the Northeast, which I know New York has customized into a nice state-specific document. But it's always a good idea to understand not only prices, but the direction in which things may be going in your region. I don't want to take up any more of your time at this late in the day. So on the next slide, I think you'll just see our contact information. Please feel free to reach out. As I mentioned, Juan runs point on our Energy Emergency Assurance Coordinators, or ESF-12 contact list. Please make sure we have a main contact and a backup for your state or territory. It's really important that we get the information to the right people and can receive it from them. So with that, Sarah, I'm going to hand it back to you at NASEO, and I'm happy to take any questions that folks might have. But I understand we are late in the day here, and thanks again to everybody for sticking around, and thanks to NASEO for putting on a great webinar as usual.
Yeah, I appreciate it, Megan. And I know Megan used to be on the other side of this, used to be co-host with Ben, so it's always good to see a familiar face. Yeah, and thanks again for sticking around. I see we have 70 folks on, so this is a good number we're working with. Megan, I had a couple of questions for you. I know sometimes you have the situational awareness team come on, and they're a great resource for you all. Could you speak a little bit how they could potentially be a great resource for our state members? Just a little bit into that.
Right. Well, I'll say that the situational awareness team provides us with a heck of a lot of great information. They're out there always monitoring energy markets, and in fact, they are on the call. And I wonder, Matt, if Sarah can unmute you, if you might want to talk a little bit about how you can be a resource for states. Do you see Mr. Tarduano on the call, Sarah? Awesome. Perfect.
Yeah, can you hear me?
We can. Thanks, Matt.
No, I mean, I don't know if I have anything specific to say, about states. Obviously, we're constantly monitoring anything that's happening, and anything that potentially is impacting the energy sector across the U.S. And then more specifically, when things do happen, what the impacts are and what the impacts could be. And I think that's where when there's disruptions that are more unusual than sort of the standard disruptions, providing that sort of insight into what the other considerations are, what the considerations, in the near future might be, are the types of things we are working to produce to help our various partners, including our SLTT partners. So, that's one piece. And then, obviously, when there's a major incident, we're issuing situation reports, including a version that goes to, all of the state partners on the call. So.
Right. And I'll mention Matt is, the driving force behind Eagle Eye. He and his team designed that. It's a great resource for folks. And if you are looking for outage information that's kind of older than the last 30 days or so, please feel free to reach out to SLTT. We can make sure we can funnel things over to Matt's team and make sure that we can get you data that you need from Eagle Eye. These guys do a lot of great and interesting work tracking all of these outages. Although they weren't able to help me get my power back on last week. I have, something to say about that. No, I'm kidding. But they are a great resource for us. So please feel free to reach out if you think there's something that we can, if you need a situation report, or if you want to dig deeper into sort of county level or 15-minute outage data via Eagle Eye. This is the team that does it. And they also can help coordinate waivers. I should have mentioned that too. They will help coordinate regional waivers should we need them. So again, we like to see that justification come from the states. Why do we need it? What is it? But Matt's team has been really, really helpful in those instances in the past as well.
I appreciate that. And Matt, thanks for jumping in off the gun here. We had a question come through kind of related to all the presentations given, but will slides and notes be available after this presentation? Yes, we will post this online on NASEO's YouTube channel, and we'll attach those slides too, so you can get all those QR codes and links. But again, a lot of this information can be found online, as folks have mentioned. Megan, I'll just wrap up with this one question. I know we've heard a lot about how this hurricane season is going to be different. How maybe is the Department of Energy approaching this hurricane season differently, if at all?
Well, I look over at my colleague Matt too to see if he's got anything to add on this one. I don't think we would approach it differently. I think that we're always trying to, like I said, it's a continuous improvement cycle, right? Like we want to monitor all the right data. We always want to do it better than we did last year. This looks to be like it might be get really, really interesting out there. So I'm not sure, Matt, if you've got some ideas about, are you approaching?
No, I mean,
this?
yeah, we don't approach it different. Obviously the forecast for the Atlantic is, calling for a, fairly significantly above average season, but it's always important to note that that's not a landfall forecast. That is just a storm forecast for the whole basin. We are constantly monitoring storms this time of year, and we're starting this time of year and looking for anything that might be heading towards the U.S. and U.S. interests. But I think as Megan was saying, obviously we do after action reports after every hurricane season and after every major incident, and so just taking those learnings to incorporate them into how we respond moving forward to try to make it more efficient and better coordinate each and every time. And that's, we also look towards the Pacific Basin. The Central and the Eastern Pacific Basins don't have they're below average forecasts, and then there's no real forecast for the Western Pacific and the South Pacific, but always sort of front of mind out there as well. So not approaching it any different. It's just always improving on what we've done in the past.
Appreciate that. Yeah, definitely an all hazards approach, it seems, with all these things that are always going on. Matt, I see you have your hand up. You want to jump in here?
So we do have an outlook for the West Pacific that is created within NOAA. I can share the link to this group. I gotta just kind of find it right now. And it's each, like CNMI, Republic of Palau, each one of the EEZs for those states or for those countries. It's based on that. It's not for the entire West Pacific, so it's a little bit different. I can go dig that up and share it to you, Sarah, if you want to plaster it on the bottom of a slide or something.
Definitely. Awesome. Yeah, I appreciate that. Well, I just want to thank Megan and Matt for jumping in here last minute. I think I'll give you 3 minutes left of your day since you stuck around for almost 2 hours at this point. Again, thanks you to the states and territories that are joining us today, and DOE CESER and all our speakers here. And with that, have a great afternoon or morning, depending where you're at.
Thanks, Sarah.
Thanks, everybody.